Okay, so let's look at some different ways to optimize our scene. Now, I'm assuming that you are happy with your final render and everything is looking good. And now we just need to clean up the scene and make sure we're not wasting time on our renders. So in a studio environment, we can render up to 8K at 60 FPS on hours of content. So saving even 30 seconds per frame can amount to days even of savings on overall scene build time and or render time. It's important within a production pipeline to make sure that we are creating clean and efficient assets for when we pass this on to the next stage, whether that be LRC or look dev. So a few things to bear in mind is to make sure you have saved out all your geometry, removing any unnecessary build time, deleting any unnecessary geometry, geo and textures from the scene, and this is just to keep it clean more than anything. Converting all your textures into TX files. And we already mentioned previously what these were, but when we get to converting these, we can talk a little bit about it again. And finally, just double checking and making sure you don't have any objects that you perhaps thought you needed displacement for, that you no longer do, and you can use bump instead, just to save some render time. Okay, so for the final renders, some of the things that I like to make sure I check are removing any unneeded lights and making sure I don't have any lights on by accident, or perhaps simplifying. Maybe I have 2 lights doing the job of 1, for instance, or maybe I have the samples too high. That's another thing that you need to check, because any samples you have will be multiplied by the ROP at the end, by the pixel samples. So make sure that you don't have your light samples too high. Double check that you have all the AOVs you need for comp. And finally, to lower and reduce the render settings wherever possible. Now, we spoke about this last week, at least the practicality of how to achieve this, but we'll just briefly go over it again a bit later. Now, within a production environment, there are further considerations. Although we won't go through them in this video, it's worth mentioning because I work every day in a production environment. So, assetizing the scene is very important, and exposing the relevant parameters. We don't need to assetize it here, but this is something you would do within a production environment. And we also have splitting up the ROPs and halving the resolution or reducing the samples on certain ROPs. And this is because not all passes need to be full resolution or high samples. It could be that some backgrounds are out of focus, so maybe we put them on a separate ROP, we render them at lower resolution, and then they're blurred in comp anyway, so you won't notice. It could be that the volumes only need to be rendered at half res and scaled up in comp, because again, you won't notice because they're always nice and soft. Or perhaps you only need to render, 1 frame for your environment, and then you can split that up into layers in comp, and that way you don't have to render the whole sequence. Perhaps you only need to render it once. Okay, so we won't cover that section. I just wanted to make sure that you knew about some of this stuff. But we will work through the rest of these in the scene and double check that we have everything set up. Okay, so the first thing to check are the instances, as these are the heaviest time sink. To make sure that these are efficient, we will first create some source files for these, so Arnold scene source files, or AS files. So these files are similar to the IFD files that you get within Houdini and Mantra, and they are very robust, and they can contain all the information that we need to transfer a whole scene from one program to another. Now, there's no reason to turn everything into these. Single geometry, like Megascan's assets for instance, or volumetrics, work just fine as alembics, but scatters do save some time when instance geo is converted. Now, the scatters that we have at the moment using alembics are pretty efficient, And we do save a little time when we convert them into ASS files. But more than this, I just wanted to show you the setup if this is something that you wanted to do. So it's pretty straightforward. We just have to drop down a new ROP within our out network view here. Let me just drop down a new Arnold ROP. And we use the archive tab. So we mentioned earlier that we would come back to this. And we just have to tick export ASS file. So in this case, I'm going to export one of these trees here. So let me just navigate to where they are stored. Okay, and as you can see, I have already saved one out, so I'll just overwrite this guy. And below this, we have some toggles here. So we have all the information that we want to include, and you can see we can't export the whole scene. So for instance, if we wanted to contain the whole scene within this, we could export, the cameras and the lights and the shaders and the shapes, etc., etc. But we only want one piece of geometry. So to do this, I'll go to the main tab, and instead of this being an asterisk within candidate objects, I'm just going to find the pine tree that I want, which is pine_geo_0. And I do need to make sure that it's turned on. So let me just turn on the display flag. And within the archive tab here, I won't go through all of these guys, but for a single object, we definitely do not need the lights or the cameras. We do want the shapes, of course. And the last thing I want to enable is the astalk file, as that is the bounding box. So we want to bring this back in. So if we jump to the OBJ view and we drop down an Arnold procedural node, and navigate to the ASS file you just exported, which is here. And let's take a look at what that is. Here we have the bounding box. If we switch to field geometry, it just looks the same anyway. We can override the material, and we should enable these Arnold settings here. So let's make sure these are all switched on, as these are the defaults on any GeoNode. Nice. So let's see what this renders like. I will just add a new Arnold ROP here, just so I don't affect the previous one. Everything is fine, and make sure to have export reference materials enabled, and let me half the resolution for now. Let's name this test. Oh, I've left the background instance on. Let's switch this off to speed up the render. Okay, so this is our procedural, and what we want to do is create a new scatter just to compare the two, where we have the procedural in one and the Pine Geo in the other. So let me just duplicate this guy over. I'll call this Pro for procedural, and I'll make another. Just call this ABC. I don't need this point node. I was using this to create the instance that we previously had done within the Wrangle. So let me just remove that on both. And I will point this one to the procedural. and this one to the alembic. And let's just render these one at a time, and we'll take a look at which one renders faster. So what I'll do is I'll start timing it from when I press render, and we'll just see which one's quicker. Let's start with the procedural. Okay, so that was pretty quick. And now for the alembic. Okay, so they're pretty comparable, but this is on half res with low samples. So if we were to crank this up, we would multiply how much time we saved. And as we mentioned at the beginning, if I was rendering a whole sequence where everything had to be as efficient as possible, and we were rendering the 2 hour long animation at 60 frames per second, then we would in effect save quite a lot of time. But for my single frame renders at home, or even just my short sequences, taking the extra step to convert everything to scene source files, isn't really worthwhile for me. But if I was rendering a longer sequence at home, I probably would. Now, really, I wanted to show you this just to show you that you can. If we look at the color of the trees, we see it does change. That's partly because within the shader, in the pine node here, we have our color jitters, which are creating the color variation. Now, because we are using procedural nodes, instead of using the per object variation here, we should use the per procedural. So we can just transfer this information onto here, and it should be similar. It might not be the same because the seed value will probably change, but it should be similar. So that's just a heads up if you do experience a change when switching over to scene source files. Now we have all our scatters saved out, we need to go through all our assets and just make sure we don't have any builds going on. So by that, I mean this, and I am guilty of this. Here's one here, where After I have brought it back in, I have made some changes. So before rendering this, Houdini needs to build this, rather than just loading it from disk. So what you need to do is go through the whole scene and make sure that the last thing in your flow is the ROP. So essentially I would just move this up here instead, and then render this back out and bring it back in. And I just need to make sure I do that for the whole scene, including the point clouds in the instance nodes. Once this has been done, I'd clear the scene of any geometry, volumes or lights that have been sitting around that I don't need. So next up is the shaders. And what I want to do here is just make sure that all of the image files that we have coming into the scene are .tx files. Now .tx files are, as mentioned before, similar to Mantra's RAT files, so they only load what you need. Now Arnold should automatically generate and look for these files, but it's good practice just to make sure, especially in a production environment, since you don't know who might be picking up this asset or what their ROP settings might be, that these are definitely set to the TX versions. So we might not be able to see them. If we want to see them properly, we have to change this to an asterisk. And then they should pop up, after which we can navigate and find them. So here's this one. Yep. And now I know that this is pointing to the TX file. So I could just go through the whole shader here and make sure that's set up. At home, if it's just yourself, maybe you don't need to do this, but you know, it's just efficient, and within a production environment, it's very important. So now you have all your assets in your scene, which means you could and should probably have already reduced the geometry based on the distance to the camera. And you know exactly how far away everything is, and you're happy with your render. You can ask yourself things like, perhaps on the faraway hills, do I need displacement on these guys? Can I just get away with bump? Could I split off this whole mountain and get away with bump, you know, to save some render times? Say I have some rocks or trees over here. Do they have displacement on them? Can they just be bump? Do I even need them? Can I remove them? Do they add anything to the image? Because as you're building your environment, you will try lots of different things, and you'll bring lots of things in that perhaps you don't actually need in the end. The other question is, does this texture really need to be 4K? You know, it may be that you have just downloaded the highest version from whatever website, but all of this builds into the memory and adds into the memory, and obviously larger textures take up larger space. And all of these small things can dramatically reduce your render times. So next up, let's take a look at the lights. So here, for instance, I have 4 volume samples on the environment light. And the reason I have that is because I have the volume ROP, right? And there was some noise within the volume, so I upped the samples here. But it may be that you don't need it, and you can just remove that. It may be that you have accidentally upped the samples here. Maybe in an attempt to reduce some noise, you've cranked these up, and then you've multiplied these with your pixel samples in the end. So definitely go back and reduce this stuff. So sometimes it is worth bringing in a blurred version of the HDR and using that as the scene lighting or the sky lighting, with the full version reserved only for the specular contribution. And this can help reduce noise caused by the hotspots in the HDR. Now, of course, you can only do this if you're not already using the HDR to cast the shadows in your scene. So what we would do here is, within the contribution, we would perhaps just remove this guy from the specular and make this the blurred HDR, and then create another one. And within here, this would only affect the specular. So this is what would do your reflections, essentially. Now, it may be that you don't actually get any noise from the first HDR, and in which case that's fine. So finally, let's check out the ROP. So the first step would be setting up the ROPs for our layers. So this could be characters, environments, effects, and volumes. For us, it's just environments and volumes. So we could also set up our Arnold fog here and make sure that our bundles are correct. We demonstrated this within the Arnold fog and the Arnold atmosphere video, to make sure our mats are properly set up. And it's always worth doing one final low sample check to make sure that it's all correct before sending your final renders. So within the ROP, as we mentioned before, the lower the better. So let's look at the samples. It's worth going through each one of these and reducing it to see how it affects your scene, and only increasing it if lowering it or removing it begins to affect the quality or introduce artifacts. Same with the ray depth here. For instance, this specular doesn't need to be at 2, 1 is fine. Perhaps the transmission doesn't need to be at 8. In general, it's good to send low quality image first and do a quick comp pass within your compositing package to make sure that you have everything you need before again sending your final frame and waiting for a long render. So your HQR or your high quality render samples depend on the scene. For my final one, I used a max of 8 and a min of 5, and these were enough for me. With the Atmos, although I rendered this at full frame, I probably could have rendered this at half resolution. And in comp, I could have scaled it back up to make it full res, and you probably would not have noticed the difference, but I would have saved some render time. Okay, so the last step would be to double check your AOVs, make sure that you have everything you need. Again, we demonstrated these previously within the output tab. Just down here, make sure you have everything you need. Choose your location for choose your camera. That needs to be set up properly here. Choose your location and the frame range, and make sure this is set up for what you need, and then hit render. Next up, we'll take a look at grabbing Fusion 9 and taking an overview of the program, and then doing a quick slap comp. Thanks.